Okay. Now, let's look at example 6. Write an equation from a graph. A scenic train ride makes trips on an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as a function of time? What is this domain? So we're going to represent an equation looking at the graph. So as you can see, the x-axis and the x-axis, you have a label that says time since start in minutes. And y represents distance from station in kilometers. So the graph represents the distance away from the station, right? Over a period of time. So your graph is starting from 0, 0, your origin. And that means at 0 minutes before you even started, the distance is 0 kilometers away. So it is at the station. And after the time passes by minutes, the train is going further and further away from the station because the distance is increasing. And then at the vertex point, 15, 15, that is where it hits the maximum distance away from station, and it starts to come back again after 15 minutes at 15 kilometers away. Right? So this is an absolute value function because you have a V shape. And so your parent function is f of x is equal to absolute value function, right? Absolute value of x. And now we want to see what kind of transformation would have made this graph look like this. So looking at the absolute value function, you have a flipped V sign. That means you have a reflection over x-axis, right? And then your vertex moves from here, from 0 to 15, and up 15, right? So right 15 and up 15. So you have a translation, horizontal translation, 15 units right, vertical translation, 15 units up, and you have a reflection over the x-axis, and then your slope may have changed. So you may have a stretch or a compression, right? So we're going to figure that out. So let's look at the vertex first because the translation is the easier part. So g of x is equal to your horizontal translation happens inside your function, so inside the absolute value. And if you're going right, you're subtracting 15, right? Right, 15 units, subtract 15. And then you're adding 15 outside the function to go up. And then you will have a stretch. So let's figure out that number a outside the function in order to figure out our stretch and the reflection, right? That should be a negative. So pick a point. 15, 15 is not a good point because if you plug in 15 into x, that will make it 0 and your variable a is gone. So you don't want to plug in 15, 15. So let's use another point, which is an easier point, 0, 0. And so when x is 0, your function with a should result in 0. When x is 0, y is also 0. So solving this, you have negative 15 here. And then a absolute value negative 15, right? So then that is just positive 15a. And that is equal to negative 15. So your a should be negative 15 divided by 15. So that is equal to negative 15 divided by positive 15, and that is equal to negative 1. So that negative represents reflection. And then that 1 just represents your stretch, which means you don't have a stretch. So it's just stretch or compression. So by a factor of 1, it's just an original slope. Okay, so your final equation should just be negative absolute value x minus 15, absolute value, plus 15. So your final equation should be negative absolute value x minus 15, absolute value close, plus 15. Okay, this is your final equation. All right, so describing the transformation and writing the function looking at the graph using the transformations of functions would be part of the skills that you need to know. And then we want to figure out the domain. So what is your domain? From which number to which number would x values possible? In this case, you're starting from 0, and then you're going to end with 30 minutes, right? After you reach the station, you don't count anymore. So it doesn't exist in this situation. So from 0 to 30 would be your domain. You can write it as an interval notation, 0, 30 brackets. Okay. All right, so let's look at try number 6. How would the graph and equation be affected if the train traveled twice as far in the same amount of time? So what if the time is shorter, right? Because if the train travels twice as far in the same amount of time, that means in less time you will do the same thing. All right, you're keeping the time. So sorry. And then your train the distance is changing double. So instead of 15, 15, you're doubling that and going up in the same amount of time. And then you have 15, 30. Because in the same amount of time, you're doubling up the distance, right? Then you would have a stretch or compression. So there would be a vertical stretch by a factor of 2. So the new equation should be negative 2, absolute value, x minus 15, absolute value close, plus 15. So let's write that down. There would be a vertical stretch by a factor of 2. The new equation is, let me write that down. Y is equal to negative 2. You still have a reflection because the V shape doesn't change, right? X minus 15 plus 15. Okay, that was try number 6, example 6. So summarizing our lesson 2, transformations of functions. We have a horizontal translation, vertical translation, reflection across the x-axis, reflection across the y-axis, and a horizontal stretch or compression, or vertical stretch or compression. We have examples here with equations and graphs. So please practice how to write equations by looking at the graphs, or graphing them by looking at the equations using transformations. Thanks guys. We'll continue the next lesson in the next video. Bye.